So here I'm going to have just outside changes. I'm going to square that g function, and I'm going to subtract two groups of the f function. Okay, so again, we should be using brackets here. So we have x squared plus 5 squared. Okay, and I'll write that. Maybe I'll keep that in black brackets here. So there's my g of x squared minus 2 times my f function. Okay, so I'm going to replace the f of x with the f function, 4x squared minus 3x. Okay, so there I've done my replacement. Okay, there's only an outside replacement here. This is an equivalent expression to this function notation. At this point, we want to just combine the like terms to simplify this expression. So I'm going to expand this out. x4, please don't square and square. We cannot square across pluses. We need to expand this. So it's going to be plus 5x squared when we do the FOIL. So I end up with 10x squared plus 25 minus, expand this to get 8x squared plus, be careful that negative times negative is plus 6x. Okay, so again, just a note on the side here, when we expand x squared plus 5 squared, we have to make a squared with x squared plus 5. We get x4, 5x squared, 5x squared, and 25. So that's where I got this expression from when I squared that x squared plus 5. Okay, we can't just square x squared and 5. Okay, it doesn't work that way. We can then combine our like terms. x4 plus 2x squared, and then plus 6x plus 25 after we combine all our like terms. And then lastly here we have, this now is a little bit different because I have the outside f, and inside of f I have the g function. So what that means is I have to replace the x's in the f function with whatever g is. Okay, so let's just kind of think about this. So f function, if I go back to my f function, it was 4x squared minus 3x. So I'm going to do an inside replacement. So I have 4x squared minus 3x. Okay, so that's going to be the f function. So I'm just going to write out the rest here, minus 2 times g function, my g of x. Okay, so here's my g of x function here. Okay, so I just want to kind of make sure that I know what I'm doing here. So this is, I can replace my g with x squared plus 5 because there's no inside here. It's just dealing with the g on and the minus times negative 2 on the outside. The inside here I have to replace with g. So I'm just going to put g in there like that, g of x. G of x. So I'm putting the g wherever the x was. Well, what that really means is I'm going to replace that g with that x expression. So I end up with 4, there's my x squared minus 3x. And then this part here, I'll just work this out because I think we kind of dealt with this. So negative 2x squared minus 10. Here we're going to replace the g with the g function. The g function was x squared plus 5. So I'm inputting x squared plus 5 into the f function. So I've embedded one function, g, inside the other function, f. And that means that wherever there's an x, I replace that x with a g function. So now I've done all my replacements, and I can just work this out and simplify this. So I end up with 4. Remember, when we square this, we're going to end up with x4 plus 5x squared plus 5x squared, which is 10x, plus 25 minus 3x squared. Again, make sure you're keeping brackets. Keep track of all those negatives. Minus 2x squared minus 10. So I end up with 4x4 plus 40, so this should be squared, 40x squared plus 100 minus 3x squared. I'm going to combine those, actually I'm going to combine these like terms here, so it's going to be minus 5x squared minus 25, and then combine my like terms, 4x4 plus 35x squared. 100 minus 25 is plus 75. So there is my expression for f of g of x minus 2 times g of x. Okay, so we end up with this expression with x's.